All right, so example 3, we are taking 2 times the quantity, 1 minus x, plus 3 equals negative 8. And we need to solve for x. So we need to get x by itself. And this is a prime example of like a problem that it's not easy just to guess and check what x is, right? Like that would take a lot of work. So we need to actually use our steps to solve. Zegan.
I would take 3 off of each side, right?
You could do that, but according to our DCAM, what should we do first?
Do the parentheses first, right?
Do the distributing first. You could subtract 3 from both sides, but I'm going to have us just always do the same order. Okay, Leah?
Is the first one thing inside the parentheses a 1?
That is a 1. Yes, sorry, it's a little
It's a special one.
it's a little tilted. Okay. So, according to our mnemonic device, don't call after midnight, our first step should be to distribute. We need to distribute that 2 into the parentheses. Okay? So, I'm going to show you 2 ways to solve this. First, we'll do it by distributing. Then we'll do it Zegan's way. Okay, so method 1, which is why I put that little Roman numeral, is to distribute. So to distribute that 2 into the parentheses. 2 times 1 is 2. 2 times negative x would be what? Negative 2x. And then just bring everything else down. So 2 minus 2x plus 3 equals negative 8. So everything else kind of stays the same. Okay, the C, that would be our next step. C stands for combine like terms. Do we have any like terms on either side that we could combine? Yes, what should we combine? Again?
You should combine 3 and 2.
Very good. 3 and 2 equals 5. We don't do anything to the negative 2x. That just comes down. And now we're set to continue to solve sort of in the way we know how, right? Our mnemonic device says add or subtract, multiply or divide. What I like to do is cover up your variable term and get rid of whatever else is happening. So in this case, what should we do on both sides?
Add 5.
Minus 5.
Subtract 5 on both sides.
This is a
Yes.
ratio?
Yes.
Why? How did you get rid of the 2 on the left side? Because isn't that a positive 2? So when you need to take away 2, so
I
it'd be 1?
first I combined the like terms.
Oh, you just made it 5.
And
Got
yes,
it.
so I made it 5.
Got it.
Okay, so we're going to subtract 5 on both sides. So we end up with negative 2x, I'll bring that down, is equal to what? Negative 13. Good. Okay, and remember, my coefficient means multiplication, right? Negative 2 times x. So the inverse of multiplication would be divide. And we're going to divide both sides by what?
2.
Negative 2. Negative 2. It's going to be a decimal. So yes.
7.5.
Yes.
No, it's
6.5.
Good job, everyone.
Okay. Yes. So it will be x equals 6.5 or 6.5. Here is your helpful note. Decimals and fractions will be solutions. So if you get a fraction or you get a decimal, don't start thinking you're wrong, as may have been the case in earlier years of math. Now they will indeed be possibilities. Okay, so just know that. So x equals 6.5. Let's look at the other way to do this. I would like you to write this down as well. So just either do another column or you can do it down below. But this is what you were saying, Zegan, is we sort of can get the variable by itself without doing the distribution. So subtracting 3 on both sides would be what we do first. And then bring everything down. You guys with me so far? I'll give you a second to catch up on your writing. Now, I don't like this method as much because you're going to end up with your decimal earlier in the problem, and like it's a pain to work with decimals and fractions. It's easier to work with whole numbers. So the last one was nice because that was our very last step. In this one, in this method, what we could do rather than distributing is divide, because technically what does this 2 mean? 2 times. We could do this inverse operation right here. Divide by 2, divide by 2. Sometimes this is more helpful. It depends on the problem. If this was an even number, then we'd get that x almost by itself more quickly. It's not necessarily better on this problem, but I just want you guys to see it so that you know that this is an option. Divide both sides by 2 so that we get rid of that 2 out in front. And then we remove the parentheses. And when we do our division, negative 11 divided by 2, we get that decimal, negative 5.5. Okay, so I removed, did you guys see that? Let me go back. When we have the parentheses by itself, like that, at that point, once it's alone, you can just take the parentheses off. And then you just end up with 1 minus x, right?
Did you do negative 11 divided by 2?
Yes, can you see that says negative 5.5?
Oh, that looks like negative 50.
Yeah, you can barely see the decimal, but it's 5.5. Okay, so what we can do is take away the parentheses, right? And then we just do our regular, cover up our variable. We have positive 1. So we should subtract 1 from both sides. Make sure when you bring down, there's still a negative sign in front of this x. Don't lose that, because that'll mess up your answer. There's still a negative sign in front of the x. Remember that when we are fully solved, the x or the variable is by itself in positive. So in this case, it's by itself, but it's not positive yet. How do we make that positive? What's technically in front of that x, Malia?
Oh, I was gonna say they're both negative.
Yes.
When they're both negatives, don't they just equal positive?
Yes, but algebraically, right? I'm going to always push you guys to tell me algebraically. Technically, what is in front of that x?
Subtract.
What number? What number is in front of that x? What's the coefficient of x?
1.
What kind of one?
Negative.
A negative one. Would you agree that this is actually this?
Negative 1x?
Yeah.
Yep.
Yeah. So how do we get rid of that negative 1?
By adding x, right?
Do what?
Just work the 1.
How do we get rid of the 1? The negative 1?
To add 1.
What operation are we doing here?
Multiplication.
Max?
The negatives can just cancel out, right?
How? Algebraically, how do we cancel the negatives out? What are we technically doing? Multiplication. Negative 1x really means negative 1 times x. How do we get rid of that negative 1? By what?
By 1.
What kind of 1?
Negative 1.
Yes. Divide both sides by a negative
Why would it be a negative 1?
1.
Negative 1 divided by negative
Because it's negative 1x.
Yep. So hold on, if I go back.
So you wouldn't do the reciprocal on division?
No, you are doing the, well, you're doing, no, you would not do the reciprocal, you do the inverse operation. So the inverse operation, this is technically negative 1 times x,
Yeah.
right? And so to get rid of that, we do the inverse operation of multiplication, which is division,
Yeah.
right? If you had 4x, you would divide both sides by 4, right?
Yeah.
But now we have negative 1x, so we're going to divide both sides by negative 1. And when we do that, then yes, as you guys are all saying, it cancels the negatives out. But how we do that is by dividing both sides by a negative, because a negative divided by a negative gives us a positive number. Okay? Yeah, I do think the other way was easier for this problem. Sometimes this way is easier. It just depends. Okay, moving on. Are we ready to move on?
Yeah.
Okay. Okay, I'm going to have you copy this down. This is our little word problem. This is our little real life application. This will always kind of be toward the end of our lesson. We'll do a word problem that shows the real life application of the math that we're learning. This is a classic algebra problem. Like, this is something you'll see on like high school entrance exams and on the ACT and the SAT. They love this kind of thing. So here's what we've got, a little chart. We've got days of the week, Monday, Tuesday, Wednesday, Thursday, and then we have miles. So this is going to be, I think someone's running or biking or something every day. So just sort of copy the little chart, and here's what they're doing. This is how much I can't remember if it's running or biking, but we'll see. This is how far they went. 3.5 on Monday, 5.5 on Tuesday, 0 on Wednesday, and 5 on Thursday. And then here's our problem. This is what they tell us. Use the table to find the number of miles you would need to bike on Friday for a mean of 5 miles over all 5 days, Monday through Friday. How are you going to get to a mean? What's another word for mean? Average, yes. For an average of 5 miles. So first of all, we need to remember, how do we find the mean or the average of a set of numbers?
You add all the numbers together, then
Yes.
divide by the amount.
Very good. Add all the numbers together, then divide by the amount of numbers that you have, right? So in this case, it would be the total number of miles divided by the number of days. How are we going to set this up? Amanda, what do you think? Or do you have a question?
What is the first week saying?
Where? Here? Here? Oh yeah, use. That's like with a real badass. Use the table. Okay. The trick here, and this is where people get confused, what do we not have in our chart that's going to help us on this problem? Friday. And how many miles did we ride Friday? We don't know. We need to figure that out. What should we call that? Yes. Let's call that our X. Because we need to solve for that to figure it out. Now from here, we need to set up our average, like our formula for the average, in order to figure out that X. So we know the average is the total number of miles over the number of days. And what do we want this average to be? What did the problem tell us? A mean of, yeah, right? That's going to be our average. We want that to be what this ends up equaling. We want the average to be 5. So we're going to put that in as we solve. On the top, we need to figure out the total number of miles. So we're going to add all of the miles together. 3.5 plus 5.5. We're not going to add 0 because that doesn't help us at all. Plus 5. Plus what? Plus X. Don't forget that X. That's super important.
So 14 plus X.
Is that what it ends up being? Yeah, 14 plus X. What goes on the bottom? How many days are we looking at? 5 days. This is the most crucial step right here, is setting this up. Okay? So remember, average is the total number of miles or no number of whatever added together over the number of days. Okay? So then we have to figure out how to solve for X. So let's simplify on the top. So we end up with 5 equals 14 plus X over 5. And we need to solve for X. The first thing we want to do is we're going to want to get rid of that 5 underneath, because we can't really do anything on the top until we get rid of that 5 underneath. And remember, a fraction bar means what operation? Division. So we are doing 14 plus X divided by 5. So in order to get rid of that 5, we should do the inverse operation.
Multiply.
Yeah. If we multiply by 5, right?
Yeah.
We get rid of that 5. And if we do it on one side, do it to the other. I'm going to move over here because I'm running out of space. So then we end up with 25 is equal to 14 plus X. So then to solve for X, what should we do?
Subtract 14.
Subtract 14 from both sides. Subtract 14. Good.
That's 11 equals that.
Yes. 11 equals x. But remember with the word problem, what is it specifically asking for? 11 what? Yes, 11 miles. You would have to ride 11 miles on Friday in order to get that average to be 5. Good?
Oh,
Okay. You will see one like this on your homework. So use your notes. Yeah. Okay.
What will we be doing in class?
We'll start in class. Oh gosh. Skip. Don't look at this. It's super stressful. Okay. I want to show you one more thing because this also is going to show up. Couple of notes. Hold on. Oh gosh. Oh gracious. Okay. We saw this on the one, but I want to just make sure that we are all comfortable with it. Remember that for you to be done with the problem and have it solved, the variable needs to be by itself and positive. Okay? So like here's another example, negative x plus 4 equals 8. Let's solve for x, making sure that our variable is by itself and positive by the time that we're done. Negative x plus 4 equals 8. And we're going to get the variable, we're going to solve, which means get the variable by itself and positive. All right, if I cover up my variable term, I cover up that negative x, I'm left with plus 4, meaning what's my first step? Minus 4. I should subtract 4 on both sides. So then I get negative x is equal to 4. And I'm not done because why?
They have to be positive.
X is not
So now you have
positive.
Can I do it now or no?
Tell me what to do, Edward.
You gotta put the 1 in between the negative and the x.
Right, because there's technically a 1 out here.
And then you divide it by negative 1.
Perfect.
On each side.
Good.
And then that'll get you x equals 4.
What kind of a 4?
And negative.
Negative 4, because the signs are different. So my answer is negative when I'm dividing. Okay, so just when you come to this issue, which you will, and you'll end up with a negative variable, like negative x equals something, make sure you divide both sides by a negative and use your rules, right? If the signs are the same, it's positive. If the signs are different, it's negative for multiplication and division. All right. No. Hold on. I'm going to need to erase that.
that thing is fast. It's so speedy.
Don't erase yours. I'm just erasing mine because, like, clearly I've forgotten what I wrote. Okay. I want you to write this down because this also shows up in this chapter, and this is kind of a building block that we'll use for the rest of the year. Okay. Math vocabulary. So this is like when we see something written out with words, it translates to a math symbol. So if you see the word sum or add, what math symbol does that translate to?
Plus.
A plus sign, right? When you see minus or the difference, so the difference is the answer to what kind of a problem?
Division.
Subtraction. So if you see minus or the difference between, that means we are subtracting. If you see the product or multiply or times, that should say times. The product is the answer to a multiplication problem.
And right?
Yes. Thank you. Of. That's a super important one, actually. Okay. That means you would use a dot or the times, right? You're multiplying. And finally, the quotient is division or divided by. Means you divide. So being able, part of what we'll practice in this lesson is being able to take words, turn them into equations, and then solve. So like they're going to give you words, you need to turn it into a math sentence using symbols and numbers, and then be able to solve. All right, So the last one is. The word is should be substituted for an equal sign. For an equal sign. So these are my little symbols. I've got crossed out, but not on purpose. Is means equal sign. So the tiny words are usually the trickiest ones, but they're also, because they're so important, but they're so little, right? So is super important, even though it's a really little word. Let's practice. Are we ready to move? Ready to move on? All right. I'm going to go back. Okay, let's do this one first. Okay, so here's our word sentence. 4 times the difference of a number and 7 is 1.
Oh, good grief.
Right? So we need to take this and turn it into like math symbols so that we can solve for the number. 4 times the difference of a number and 7 is 1. So what I like to do with these is I like to like write it up above so that I can sort of take the words and turn it into numbers and symbols. So 4 is obviously 4. Times means multiply, so a dot or an X. I usually use the dot just so you don't get it confused with a variable. The difference of a number and 7. So the subtraction is the trickiest part of this. The difference of a number and 7 is going to mean,
X minus 7.
yes, X minus 7. So the difference between X and 7. So X minus 7 if we call our number X. And is 1 means what? Equals 1.
What about
Oops. Of, in this case, doesn't mean multiply because it's actually, it's, to get grammar on you, it's functioning as a preposition here and not functioning as, so don't get too caught up with of right now. Okay? Now let's rewrite this. What we said is 4 times the difference of a number and 7 is 1. What's weird about how this is written and what do we need to add here? Parentheses, where?
Negative
Before
7.
the X or before X after 7.
Yeah, because we are multiplying 4 times that entire difference, right? So we need to make sure we put parentheses around this to do it correctly. And now we would use our don't call after midnight because the second part of this is going to be to solve for X. So distribute. 4 times X is 4X. 4 times the negative 7 is
28.
negative 28 equals 1. I'm going to go up here. Okay. If I cover up my variable term, I would first need to add 28 to both sides. And then I'm going to go up over here. Get rid of that. I get 4x equals 29. This is what happens when I make up my own problems, is we get really weird answers. Okay, then divide by 4. And I would leave this if I were you. I would just call this x equals 29 fourths. Because that is simplest form.
What?
Sus.
But pretty much we're just being lazy and don't want to do 20.
No, leave it. No, leave it. No. Leave it. Okay, let's do one more. Hold on. Hold on. I gotta erase.
I'm good with being lazy.
Yeah, just, go easy. Go easy on yourself. Here we go. Let's do one more. So take it from the number sentence. 6 times the sum of a number and 15, is negative 42. Stop there. 6 times the sum of a number and 15 is negative 42. Rewrite this as an equation. Watch for parentheses. So how we did it last time, I'll rewrite this one up here just because it'll be a good model. Oh, that's why it was so weird. 'Cause I didn't write it right. Okay. Number 2, 6 times the sum of a number and 15 is negative 42. How would we write this as an equation? So again,
So we have the 6. And
Yep.
we also have the time.
good.
That's going to be 6 with a dot next to it.
Okay.
And then the sum of a number and 15 is 42. The sum of a number, that's probably going to be x.
Good.
And then you're going to, because it's a sum,
Yep.
you're going to want to add it with 15.
Perfect.
That from x to 15 is going to be your parentheses.
Yes.
And then equals negative 42.
Perfect. Perfect.
We're done.
6 times the quantity. So when we see this, this is how we say it. 6 times the quantity, x plus 15. That means it's in parentheses. Is equal to negative 42. Can you solve?
Yeah.
Now this would be in a situation where it might be easier to do our division first rather than distribute. Would this be easy?
Yeah, because negative 42.
Yes. Yeah, exactly. Because it ends up giving us a whole number. And rather than having to do 6 times 15, which is going to be a big number, it keeps our numbers small, which everyone loves a small number,
Yeah.
right?
What was that clause?
So x plus 15 equals,
Negro sign.
yeah.
What? Negative 7. Oh.
What do we get? X equals?
Negative.
Nope. Do the math. Bring it over.
Add
15.
Combine and keep the sign. Yes. You have to write this out, you guys. If you try to do it in your heads, you're going to get it wrong every time, and you're going to say 8, which is wrong. We're subtracting 15 from both sides.
It's a lot of big numbers. It's like 22.
Very good. 22, negative or positive?
Negative.
Good. Negative 22. Do you want to do one more? We're good? All right. Awesome.